Hello students, in today's session we are moving forward to the topic of compass surveying, in which we will be dealing with magnetic declination, dip and local attraction. We will be breaking down the essential aspects of how compass surveying is influenced by these factors. This session aims to provide you with a comprehensive understanding of each element's function and significance in ensuring accurate and reliable surveying results. In this session, we will discuss the following key points. Firstly, the magnetic declination, second, dip of magnetic needle, and lastly, local attraction. So, first we will discuss about magnetic declination. The true meridian has been defined in earlier and the importance of its invariance has been discussed for large surveys. The exact determination of true meridian requires astronomical observations. Therefore, the measurement of true bearing in field will be tedious. On the contrary, measurement of magnetic bearing with a compass is very simple, but the Earth's magnetic poles are continually changing their position relative to the geographical poles, due to which the magnetic meridian of the Earth also changes and thus the magnetic bearings. So, what is magnetic declination? The horizontal angle between true north and magnetic north at the time of observation is defined as magnetic declination. If at the time of observation the magnetic meridian is on the eastern side of the true meridian, the angle of declination is said to be eastern or positive declination. On the other hand, if the magnetic meridian is on the western side of the true meridian, it is said to be western or negative declination. When the true and magnetic meridian coincide, the declination is 0. So, the formula for true bearing will be is equal to true bearing will be magnetic bearing plus minus magnetic declination eastward or westward. Lines connecting locations with equal magnetic declination are called isogonic lines, while those connecting locations with 0 declination are termed as agonic lines. Along agonic lines, the magnetic needle indicates both true north and magnetic north. Therefore, if the magnetic bearings are not very reliable measurements over a period of time, if over a period of time the surveyor would want to retrace the survey lines plotted by the magnetic bearings, he might find it to his utter surprise that he is not able to. So, actually the declination at any place does not remain constant, but keeps on changing from time to time. That is why we have to study about the variation of declination. So, we will be discussing about what are the variations of declination. There are basically 4 types of variations which we have to study. First one is secular variation, second is annual variation, third is diurnal variation and fourth is irregular variation. So, first we will discuss about secular variation. The earth magnetic poles are continually changing their positions relative to the geographic poles. Earth magnetic meridian also changes and affects the declination of places. Secular variation is a slow continuous change in declination of places. It alters in a more or less regular manner from year to year. Due to this magnitude, secular variation is most important for land surveyors. It appears to be periodic character and follow a sine curve. The swing of declination at a place over a period of centuries may be compared to a simple harmonic motion. A secular change from year to year is also not uniform from any given place. It is also different for different places. To convert magnetic bearings into true bearings, an accurate amount of declination is essentially required. As such, it is very important for a surveyor to know the exact amount of declination. When the observation for the declination are made in different years of century, it is revealed that the magnetic meridian moves from one side of true meridian to the other side. The change produced annually by secular variation at different places amounts from 0.02 minute to 12 minutes. The variation depends upon the geographical position of different places. The annular secular change is greatest near the middle point of a complete cycle and least at its extreme limits. Next, we will discuss about annual variation. Change in declination at a place over a period of 1 year, it is known as annual variation. From the observations made at different places over a period of 12 months, it is found that annual variation is about 1 minute to 2 minutes depending upon their geographical positions. Next, we will discuss about diurnal variation. The departure of declination from its mean value during a period of 24 hours at any place is called diurnal variation. The diurnal variation depends upon the following factors. First one, the geographical position of the place. It is greatest for the places in higher altitude and lesser near the equators. Second, season of the year. It is comparatively more in summer than in winter at same place. The time at the place, it is more in day and less at night. The year of the cycle, it is different for different years in the complete cycle of secular variation. Next and last, we will discuss about irregular variation. Abrupt changes of declination at places due to magnetic storms, earthquakes and other solar influences are called irregular variation. These disturbances may occur at any time and place and cannot be predicted. The displacement of a needle may vary in extent from 1 degree to 2 degree. Now, moving on, we will discuss what is the purpose of magnetic declination. Actually, most of the original and land survey has been in terms of magnetic bearing. During rerunning the survey lines in a future time to check their accuracy of work or to locate the direction the observed bearings may be corrected if the magnetic declination at the time of original survey and the time of resurvey are known. Now, let us take some example of how to calculate magnetic declination and how to find out true bearing if magnetic declination are given. So, taking first example, in this question it has been given the true and magnetic bearings of a line are 78 degree 45 minutes and 75 degree 30 minutes respectively. We have to calculate the magnetic declination at the place. From the formula of magnetic declination, it is difference between true bearing and magnetic bearing. So, we have true bearing 78 degree 45 minutes and magnetic bearing as 75 degree 30 minutes. We will get 3 degree 15 minutes as magnetic declination. Since the sign is positive, so declination is east of true meridian. So, final the answer will be magnetic declination will be 3 degree 15 minute east. The second question, in this question the magnetic bearing of line PQ given is 124 degree 35 minutes. We have to find the true bearing if the magnetic declination is 10 degree 10 minute west. So, in this question they have already provided the magnetic declination as 10 degree 10 minute west. So, true bearing of line is equal to magnetic bearing plus minus magnetic declination eastward or westward as we discussed earlier. But since the magnetic meridian is to the west, so true bearing will be equal to 124 degree 35 minute minus 10 degree 10 minutes, which will give you answer 114 degree 25 minutes. So, the answer true bearing will be 114 degree 25 minutes. In the third example, in the question it is given as the magnetic bearing of line PQ is south 40 degree east and the magnetic declination is 8 degree 5 minute east. We have to find out what is the true bearing of line. So, to solve this question, firstly we convert the magnetic bearing of line PQ from quadrantial bearing system to whole circle bearing system. The whole circle bearing of line PQ is equal to 180 degree minus 40 degree, which will be equal to 140 degree, since that south 40 degree is lies in the second quadrant. Now, true bearing of PQ will be equal to, as same as the previous question, magnetic bearing plus minus magnetic declination eastward or westward. So, in this question they have given magnetic declination as 8 degree 5 minute east. So, answer will be 140 degree plus 8 degree 5 minute, which will give you answer 148 degree 5 minute. Hence, the true bearing of line will be equal to 148 degree 5 minute. Moving on to the next question, in which we have to calculate the true bearing of line CD. If the magnetic bearing is south 50 degree 45 minute west and the declination is 3 degree 45 minute east. As the declination is eastern, magnetic meridian will be east of true meridian. So, true bearing will be equal to magnetic bearing plus declination, which is south 50 degree 45 minute west plus 3 degree 45 minute, which will give you answer south 54 degree 30 minute west. Moving on to the fifth example, in which the magnetic bearing of the sun at noon is given 175 degree. We have to show with a sketch the true bearing of sun and the magnetic declination. As we already know, the true bearing of sun at noon is equal to 180 degree, and in the question it has been given the magnetic bearing of sun at noon, which is equal to 175 degree. So, we have to calculate magnetic declination, which is equal to true bearing minus magnetic bearing. So, true bearing it is given as 180 degree and magnetic bearing is 175 degree. So, we will subtract and we will get the value of as 5 degree. As the sign is positive, the declination will be east, as you know. So, magnetic declination will be 5 degree east. So, in the last example, the question is given as the declination at a place 50 years back was 2 degree 15 minute west. The present declination is 1 degree 30 minute east. If the old magnetic bearing of line in such an area is recorded as 150 degree, we have to find out the present magnetic bearing. So, to find out the present magnetic bearing, first we have to find out the true bearing of the line at that time. So, true bearing of the line is equal to same magnetic bearing minus magnetic declination. So, it is equal to 153 degree minus 2 degree 15 minute. So, true bearing of line will be equal to 150 degree 45 minutes. Now, we can calculate the present magnetic bearing as true bearing minus magnetic declination at present. So, true bearing as we have found earlier 150 degree 45 minutes and the magnetic declination is 1 degree 30 minutes. Subtracting both, we will get answer as 149 degree 15 minutes. So, the present magnetic bearing will be equal to 149 degree 15 minute. We will be discussing about dip. What do you mean by dip? What is the purpose of dip? So, a magnetic needle is an essential feature of all the compasses. It consists of a symmetrical and slender bar of magnetized cast steel supported at its center of gravity. When suspended freely, it takes up a position parallel with the earth's magnetic lines. In horizontal projection, these lines define the magnetic meridian, and thus the longitudinal axis of the magnetic needle lies in the plane of magnetic meridian and exhibits the direction magnetic north and south. It is observed that in elevation, a magnetic needle in equilibrium is not in horizontal plane, but in plane inclined at definite angle to the horizontal. This is because in elevation the lines of magnetic earth are inclined downward towards north in northern hemisphere and also downward towards south in southern hemisphere. At equilibrium, the needle takes up a position parallel to these lines of forces and becomes inclined with the horizontal. The vertical angle made by the magnetic needle with horizontal is known as dip or inclination of the needle. The angle of dip varies from 0 degree at the equator to 90 degree at the magnetic poles. That is, its value is not constant, but varies from place to place. It is seldom necessary to measure the angle of dip in surveying, but for the needle to float in the horizontal plane while observing the bearings, a small sliding sleeve weight or rider is attached to one end of the magnetic needle. For example, on the south end in the northern hemisphere, by sliding this center weight along the needle, the balance may be achieved. Now, the line joining the loci of the places having the same value of dip are known as isoclinic lines, whereas the line joining the loci of places with no dip are called aclinic lines, such as magnetic equator. Now, moving forward, we will be dealing with the most important topic of today's session, that is local attraction. What is local attraction? North end of a freely suspended magnetic needle always points to the magnetic north if it is not influenced by any other external forces except the earth's magnetic field. It is a common experience that magnetic needle gets deflected from its normal position if placed near magnetic rocks, iron ores, cables carrying current or iron electric poles, etc. Such a disturbing force is known as local attraction. Magnetic bearings are therefore not reliable unless these are checked against the presence of local attraction at each station and their elimination. So, now we will find out how we will detect local attraction and what are the methods of its elimination. The presence of local attraction at any station may be detected by observing the fore and back bearings of the line. If the differences between fore and back bearing is 180 degree, both end stations are free from local attraction. If not, the discrepancy may be due to the following points. Firstly, an error in observation of either fore or back bearings or both. Secondly, presence of local attraction at either station or presence of local attraction at both the stations. It may be noted that the local attraction at any station affects all magnetic bearing by an equal amount, and hence included angle deduced from the affected bearing are always correct. In case the fore and back bearings of neither line of a traverse differ by permissible error of reading, the mean value of bearings of the line least affected may be accepted. The correction to the other station may be made according to the following methods. First method is by calculating the local attraction of each station and then applying the required corrections starting from the unaffected bearings. Second, by calculating the included angles at the affected stations. So, first we will take up first method by calculating local attraction at each station. So, local attraction at each station is calculated and the required corrections are applied to the observed bearings. It is most suitable for an open traverse. For a closed traverse, the method fails when some of the calculated included angles of the traverse is not equal to their theoretical sum. So, the steps involved are following. First step, we have to observe a line whose fore and back bearings differ by exactly 180 degree. In the second step, the end station of such lines are accepted free from local attraction and the bearing observed at such stations are taken to be correct. The back bearing of proceeding lines and the fore bearing of next line will also be correct, since these are observed at stations which are free from local attraction. The correct fore bearing of the preceding line or back bearing of the next line may be calculated by adding or subtracting 180 degree as the case may be, and thus correct bearing is obtained. In the fourth step, if the observed bearing is more than the correct bearing as determined in the step 3, the error at the station will be positive and therefore, the correction will be negative and vice versa. And in the last step, the bearing of the lines are thus corrected one by one in succession. So, in the second method for the elimination of local attraction is by included angles. In this method, it is more suitable for a closed traverse. It may be noted that the local attraction affect magnetic bearings observed at the station by a fixed amount and in the same direction. Therefore, the included angles deduced even from the bearings affected by the local attraction will be the two included angles at the affected station. To correct the affected bearings, the following process is carried out. Step 1. We have to calculate the interior angles of the traverse and check their sum against right angles. If there is any error observed in the bearings other than the local attraction, the theoretical sum of the included angles will not tally with some of the calculated included angles. In the second step, we have to distribute the error, if any, equally to all the angles. In the third step, we have to locate the line whose fore bearing and back bearing differ by 180 degree. The fore and back bearing of these lines are taken to be correct. In the fourth step, we have to find out the correct bearing of successive lines by using correct observed bearing and corrected included angles. Now, it may happen that in a closed traverse, no line has difference of 180 degree in its fore and back bearing. In such a case, the line with the least discrepancy is selected. Then, the fore and back bearing of this line are adjusted so as to make the difference exactly 180 degree. Now, assuming the fore bearing of this line to be correct and correct fore bearing of all the lines are calculated. Now, we will take some examples of local attraction. So, how we can determine the local attraction and how we can eliminate these local attraction. In the first question, it has been given the bearing observed in the traversing with a compass at a place where local attraction was suspected given below. So, it has been given line AB, BC, CD and DA, and we have been given fore bearing and back bearing of all these lines, and we have to find out at what station we can suspect local attraction and find the corrected bearing of these lines. So, to solve this question, the first step we have to follow is to observe a line whose fore and back bearing differ exactly by 180 degree. So, as you can see, the numerical value of the fore bearing and back bearing of line AB is same. Hence, station A and B are free from local attraction and therefore, fore bearing of BC observed at station B is accepted to be correct. Now, we will convert the quadrantial bearing system to whole circle bearing. We can easily convert it as discussed in the previous lectures. So, you can see these lines AB, BC, CD and DA have been converted into whole circle bearing system, their fore bearing and back bearings. Now, as you can see, fore bearing of BC is 120 degree, which is the correct bearing. We will add 180 degree to this to find out to correct back bearing of BC, which is equal to 120 degree plus 180 degree, which will result in 300 degrees. Now, the observed back bearing of BC is 299 degree 20 minutes. Now, we can find out the error at C will be equal to 300 degree minus 299 degree 20 minutes, which will give the result minus 40 minutes. Now, if error at C is minus 40 minutes, the correction will be equal to plus 40 minutes. Now, observed fore bearing of CD is 3 degree 20 minutes, but correction at C is plus 40 minutes. So, we can calculate correct fore bearing of CD will be equal to 3 degree 20 minutes plus 40 minutes, which will be result in 4 degrees. Now, we will be add 180 degree to find out the correct back bearing of CD, which will be equal to 4 degree plus 180 degree, which will result in 184 degree. Now, observed back bearing of CD given as 185 degree 30 minute. So, error at D will be equal to 185 degree 30 minute minus 184 degree, which will be result in 1 degree 30 minutes. So, correction at D will be minus 1 degree 30 minutes. Observed forebearing of DA is given as 265 degree, but the correction at D is minus 1 degree 30 minutes. So, we can find out the correct forebearing of DA as 265 degree minus 1 degree 30 minutes, which will result in 263 degree 30 minutes. Now, we will subtract 180 degree from correct forebearing of DA to calculate the correct back bearing of DA as 263 degree 30 minutes minus 180 degree, which will result in 83 degree 30 minutes. Now, this will be same as the observed back bearing of DA, which is given as 83 degree 30 minutes. Since the station A and B are free from local attraction, the forebearing of BC and observed at station B is accepted to be correct, and the observed back bearing of DA will also be correct. Hence, the answer of the observed back bearing of DA will be 83 degree 30 minutes. Now, these are the bearings corrected for local attraction, as you can see line AB, BC, CD and DA. These are fore bearings and back bearing, which are corrected from local attraction. We can also convert these from WCB system to quadrilateral bearing system. As you can see, these are line AB, BC, CD and DA, and these are fore bearing, back bearings, and these are the solutions. Now, we will take another example in which the question has been given as the following are the bearings taken in a running closed compass traverse while surveying in Jhansi, Allahabad. Lines have been given as line AB, BC, CD, GA and EA, and whose fore bearings and back bearings as given. We have to calculate or state firstly the stations which are affected by local attraction and by how much. Secondly, we have to determine the corrected bearings, and thirdly, we have to calculate the true bearing if the declination was 1 degree 30 minute west. So, the first step is to observe a line whose fore bearing and back bearings differ exactly by 180 degree. On inspection, we find that the fore and back bearings of line D differ exactly by 180 degree. Hence, the station D and E are free from local attraction. The fore bearing of EA is accepted to be correct. Now, we will calculate as fore bearing of EA is 259 degree 30 minutes, which is correct. We will subtract 180 degree from it to find out the correct back bearing of EA, which is 79 degree 30 minutes. Now, the observed back bearing of EA given is 79 degree. So, as you know, the error, we can find out the error at A will be equal to minus 30 minutes. Now, the correction at A will be equal to plus 30 minutes. The observed fore bearing of AB is given as 48 degree 25 minutes, but the correction applied will be plus 30 minutes. So, the corrected fore bearing of AB will be equal to 48 degree 55 minutes. Now, we will add 180 degree to find out the correct back bearing of AB, which will be equal to 48 degree 55 minutes plus 180 degree, which will result in 228 degree 55 minute. Now, observed back bearing of AB is given as 230 degree, but the error at B is 1 degree 05 minute. So, correction at B will be minus 1 degree 05 minutes. Now, observed fore bearing of BC will be 177 degree 45 minutes. We will apply correction, that is minus 1 degree 5 minutes. So, corrected fore bearing of BC will be equal to 177 degree 45 minute minus 1 degree 5 minutes, which will result in 176 degree 40 minutes. Now, we will add 180 degree to find the correct back bearing of BC, which will be equal to 356 degree 40 minutes, but the observed back bearing of BC given as 356 degree. So, the error at C will be minus 40 minutes, and hence the correction will be plus 40 minutes. So, observed fore bearing of CD will be given it is given as 104 degree 15 minutes. Hence, correction will be plus 40 minutes. So, corrected forebearing of CD will be 104 degree 55 minutes. We will add 180 degree to it to find the correct back bearing of CD, which is 284 degree 55 minutes. So, the observed bearing is of CD is 284 degree 55 minutes. Hence, you can check it, the correct back bearing is same as the observed back bearing of CD. Hence, the answer is correct. The stations affected by local attraction are A, B and C by minus 30 minutes, plus 1 degree 5 minutes and minus 40 minutes respectively. So, these are the bearings corrected for local attraction as given. So, lastly, as the magnetic declination is minus 1 degree 30 minute west, we will subtract this from the fore and back bearing to get the true bearings. Fore bearing minus declination will give you the corrected fore bearing, and back bearing minus declination will give you the corrected back bearing. Hence, you can find out each of the fore bearing and back bearing by subtracting declination from it, the corrected fore bearing and back bearing. These are the corrected fore bearings and back bearings. Dear learners, we have reached the end of today's session. I hope you find out this informative and engaging. Thank you for your attention and see you in the next class. Thank you.